Hola, physics explorers. Okay, welcome to your first screencast. You're going to be getting these relatively frequently, probably between, I would say, probably around one or two a week. You should treat these just like you would a lecture in class, so make sure to take notes. You can watch this on your computer and take notes on your iPad. That's probably the best way to do it. You probably don't want to watch it on your iPad and take notes on your iPad because you're going to be toggling back and forth between the screen watching as well as the Notability screen taking notes. So I suggest watching the screencast on another device and then taking notes on Notability. Okay, so today's screencast is going to be a follow-up on pendulums. So in class today, we ran some experiments testing the effects of different variables, those variables being mass was one of them. Actually, wait, I'm going to go to a new page here. So we tested the effect of mass as well as amplitude. Oops. Some of you were calling amplitude height. Doesn't really matter what you call it, but it was the displacement from the equilibrium. So for example, if this was your pendulum right here, this displacement from equilibrium was the amplitude. So you're testing the effect of the amplitude, changing the amplitude on the period, as well as the length. And ultimately, somewhat surprisingly to some of you, the only variable that actually affected or changed the period was when you changed the length of the string. Changing the amplitude and changing the mass at the end of the pendulum did not affect the period. Yeah, shocking, I know, right? But I saw a lot of good things happening while you were doing this test. Firstly, I saw you all conducting multiple trials. So as we talked about today at the beginning of class, multiple trials are very important because they reduce human error. If you take one time, just once, you could be off by a certain amount. Taking multiple measurements and then averaging them gives you a much better idea and allows you to be much more certain of your conclusion. So multiple trials are key for good experimentation. You are also holding variables constant. Only changing one at a time. A triangle symbol, that means change one. So for example, when you were testing the effect of mass on the period, you kept the amplitude and the length constant and only changed the mass between trials. If you had changed the mass and the amplitude, so how much mass you put on the end of the pendulum, as well as the distance that you displaced the pendulum, if you saw a change, you wouldn't know whether it was due to the mass being changed or the amplitude being changed. So the fact that you were holding variables constant and only changing one at a time was really fantastic. The last thing that I saw that I was really impressed with was the teamwork. We don't really talk about that as being an important part of the scientific process, but in our classroom it is super important. And for the challenge that I'm going to have you all do, that you all are going to do next class period, it's going to be really important that you all work as a team and that you communicate with one another. Okay, so here's the information you're going to need to know for class on Tuesday or tomorrow. I'm going to start off with a fresh page again. And first talk to you about something you already know. Okay, so for a pendulum, we've talked about two different, I guess the only quantity we've really measured is the period. But we've also talked a little bit about the frequency. So to start off, t, we're going to call, that's going to be our placeholder for period, or a variable for period. You know the period, the definition of the period, to be the time for one cycle. And a cycle is, again, the back and forth motion of the pendulum. So one full back and forth. And this is measured in seconds. And then you know the frequency to be the number of cycles per second. And the frequency, the variable for the frequency, is going to be f right there. Okay, so right away you can see there's a relationship between the period and the frequency. The period, time for one cycle, and the frequency is number of cycles per 1 second. So let's talk about relationships for a second. If we have two variables and they're directly related to one another, let's say they're x and y, and let's say x is equal to 2y. This is a direct relationship. 2 times y is equal to x, or x divided by 2 is equal to y. They are directly proportional to one another. However, if we were to say that x and y were inversely proportional to one another, we would say x is equal to 1 over y. Now, if you look at this relationship between period and frequency, you'll see that they're actually inverses of one another. The period is the time for one cycle, and the frequency is the number of cycles per second. They are inverses. So, therefore, we can say, as you guys already know, that the period, t, is equal to 1 over the frequency. Or, we can say the frequency is equal to 1 over the period. They're inversely proportional or inversely related to one another. I'm going to erase this XY business because you don't really need it, and bring this over here. So I just want you to understand again, these are inversely proportional to one another. Okay, so that is the first equation you have for a pendulum. But again, going back to what we just talked about on the previous page, won't let me go back. Okay, going back to the previous page, remember that the length of the string was the only thing that affected the period of the pendulum. And there's actually a mathematical equation that describes that relationship as well. So here it is. I'm going to give it to you right here. Period is equal to 2 pi times the square root of the length of the string divided by g, which is the acceleration due to gravity. So let's just, on the side here, define all these terms. T, remember, is equal to the period. L is equal to length, and that's the length of the string. And g is equal to the acceleration due to gravity. We're just going to call it gravity. Okay. This is a formula that I want you to be able to recognize, but I do not want you to memorize it. So, if, for example, in class I ask you tomorrow, what is, in the pendulum equation, what does L equal? You should be able to tell me, oh, it's the length of the string. Or what is G? Oh, it's the acceleration due to gravity. But I do not expect you to memorize this equation. I will give it to you. And I guess before we move on, let's also talk about these units here. So, the period is measured in seconds. The length of the string, this is important. We've been measuring the length of the string, probably you've been measuring it in class in centimeters, but for this equation you're going to need to use it in meters, and you'll see why in just a second. gravity is measured in meters per second squared. So, in order for these units to work, to cancel out, if you guys measure the length of your strings in centimeters, you're not going to get the right answer. So let's do a quick practice problem just to show you how that works. So, let's say the length of our string is 2, and let's say it's 1. It's 1 meter. The acceleration due to gravity, does anyone know what it is? I'm going to tell you. It's 9.8 meters per second. Oops. Meters per second squared. Later on in the year, we'll probably use 10. We'll round it up to 10 just for simplicity's sake. But right now, I want you to use 9.8 because it will give you a little bit more accurate of a result. So if our string is 1 meter long and the acceleration due to gravity is 9.8, we take the square root, square root of that, and multiply it all by 2 pi. That will give us the time for the string. So let's just look at the units here for a second. Notice that we have meters up here in the numerator, and in the denominator we have meters per second squared. Well, because we have meters here, in both the numerator and the denominator, we can cross out, these meters cancel out. So now, we're left with, where's my black pen? The square root of 1 over 9.8 over seconds squared. So, I'm sure you all remember your math, but when you have something divided by something else, you can also, okay, what I'm trying to say here is that this, we say 9.8 divided by seconds squared, that's actually, we can just change around our, it's not mathematical trickery, but this is the same thing as saying 1 second squared divided by 9.8. And that has to do with, you can go 1 over this, so if you divide a number by another. Have you guys done this in math class yet? Let's talk about this in class tomorrow. If you don't understand how this conversion is made, we'll talk about it. So, I'm just going to erase this and put the second squared. So this is the same thing. And then multiplied by 2 pi. And this whole thing, when you do the math all out, is equal to, this is all equal to just about 2 seconds. You'll notice that the seconds here, because we have a square root, cancels out one of them. So we left here with our answer is 2 seconds. So we have, if we have a string that is 1 meter long, the period is going to be just about 2 seconds, a little bit over 2 seconds. Okay, so I think that is all for this screencast. So you should know period and frequency and their relationships between the two of them, so here and here, and you should also be able to recognize this equation and know how to apply it for tomorrow's class. Okay, that is all. See you in class tomorrow.